So there's been a lot of discussion here locally about how to grade everybody during this time home from school. So we here at TMR, the Math Wizard, called in some of our other local wizards just to consult to see what they think. So I don't know, Gandalf, what do you think about how any kind of message for these students about grading?
You cannot pass! Get out!
Gee, Gandalf, I don't know. That sounds a little harsh to say that they're not going to pass. Do you want to rethink that? Are you sure? I mean, really, what do you want to tell these students?
You shall not pass!
I don't know. Sorry, guys. You heard the wizard. He seemed pretty emphatic. We'll continue to talk about it, but I don't know.
So welcome Chemistry 1211. This is the end of the chapter. Then there's just some reviewing and things going on in upcoming days. This is probably the last video for a while, and then it would just be Zoom conferences and such to stay in touch. 1211 had two new points, which were specific heat, which should feel vaguely familiar because we did some specific heat problems back in chapter 3. And then number 2 is no. While something is melting, its temperature does not change. When things are boiling, that's also true, that things don't change their temperature. So if you go in your kitchen and you ratchet the heat on to boil some water on your stove, water's going to boil at 100. The moment the steam is created, it's 100. The moment that the water became steam, it was 100. Both things are at 100. When you do that boil process, water at 100 becomes steam at 100. They are both 100. If you wanted to heat up the steam higher than 100, you'd have to trap it in the pot, and the steam could continue to heat above 100. Water can't go above 100. Freezing's the same way. If you look in your freezer, you might see some water ice freezing process going on. You fill up your ice cube tray, you throw it into the freezer, the water eventually becomes ice. The instant before the water became ice, it was water at 0. The moment the ice is formed, it becomes ice at 0. The temperature doesn't change when the water becomes ice or vice versa. If you watch something melt, the ice is going to melt, it's going to be 0. The water that's created is also going to be 0. They're the same temperature, even though they're different things. You can make ice colder than 0 eventually, but not until it's frozen. It has to freeze first. But that's what this section was about. When we step into the next world of quiz, there is a 1211B quiz where all the vocab comes roaring back. And at the end of the vocab practice test stuff, number 1 stays the same answer, no change. 2 stays the same answer, no change. But there will be an ask of an old equation that tells you how much heat it takes to warm or cool something. So this equation is back. Delta Q equals MC delta T from old chapters. That's an answer on the next quiz to finish that packet. That will be the last question of the quiz. Math reminders for this chapter. Grams can only lead you to calories. Kilograms can only lead you to joules. We have a variety of tables that help us make those jumps. Okay. If they want a calorie answer and they give you kilograms, you would have to start off with your kilograms and turn it into grams with dimensional analysis. 1,000 grams is 1 kilogram. Always look first to whether they want calories or joules in the answer, because that's your cue as to what path you need to follow. Joules, if they want a joule answer, you can only access joules from kilograms. So if you have a joule question, but they gave you grams, you're going to need to cancel grams to make kilograms. 1,000 grams makes a kilogram again. Before you even get out of the gate, if joules is your goal, you have to get kilograms before you do any of your math. Any problem today that involves melting, you're going to use a table 12.2, which is, no, that's a fib. Melting is table 12.3. That is the bottom table of the one from your packet. You're only going to to melt stuff, you're only going to have to multiply one number that comes from this table. Take the mass, multiply a number. If they're doing stuff at the boiling point, that's table 12.1. you're always going to take the mass and multiply just one number that comes from the table. If they heat and cool things today, we have to use a table 3-4, a thing called the specific heat, which is the top of this paper. There you're going to have to multiply two numbers, because they'll still continue to give you the mass, no matter what, we're multiplying the mass. The specific heat is coming from the table, but you also have to multiply by a change in temperature. So if they say the temperature went from 10 to 30, the temperature change there is 20. If it goes from 10 to 30, subtract those numbers to get temperature changes. But some of these questions are today going to now involve multi-step plans. For example, we'll go to the book examples. I'm on 328. 328 says you have some ice, 120 grams of ice, that we're trying to get to be steam and be 100 degrees. Well, this is going to be a three-step plan. You can't turn ice straight into steam. So step one, we're going to have to melt that ice. Okay, as long as ice is ice, steam is not achievable. So your first step is melt the ice. Once you've melted the ice though, it's going to be 0 degrees. Okay, you can't create steam while things are still 0 degrees. So what you're going to have to do is take some time and effort and energy and heat that up from 0, where it's created, up to 100, where boiling becomes a possibility. And that's going to take some time and energy and work. Then, after you do that, you're going to have to boil it. And when you boil it, now you've got steam. Okay, so it's a three-step plan. The melting and boiling plans are always simpler, because as we discussed over here a bit to the left, multiplying and boiling, you're just going to have to multiply by one number. But when we're warming the thing up, or cooling it down in other problems, we're going to have to obey that old equation and multiply by two numbers. But the mass is always going to come into play. Before we get started on the math, you want to make sure the units are going to be okay. So they want a calorie answer. They're starting us with grams. Grams can lead us to calories, so 120 is fine. 120 is going to get used at every level to multiply. Multiply the mass by magic numbers that we're grabbing from our tables. So we're working grams, we're trying to work the calories. So melting ice, we need to go to the middle table of the bottom table of the group. Melting ice, we're going to look at the water category, water ice, same thing. Okay, so the calorie gram number for the water ice table at the bottom of the tables, we're going to have to use the 80. I'll skip this one for a second. If I'm boiling, that's real similar. I'm going to just multiply one number, but from the different table. The water steam kind of number is from table 12.1. That is going to get me a 540. To heat it up, I need to grab a number from the top table. Okay, water's specific heat is 1, so that's handy. And then we need a temperature change. If we're going from 0 to 100, that's changing by 100 degrees. 100 minus 0 is 100. If you multiply this out, you don't have to write it down, but it would be 9,600. If you multiply this out, you don't have to write it down, but it's 12,000. If you multiply this out, you don't have to write it down, it's 64,800. But what you do have to do is add up those three layers, and it's 86,400 calories. Try a couple more. The example 12.7 says we want calories, so we hope they give us grams, and they do. So good, I don't have to change anything at the beginning or end of the problem. They want calories, they give grams, we're good. The gram count is 450. So at every level of my problem, I'm going to have to use 450. The mass gets used at every level to multiply. Then I'm going to read through and just kind of think through what this is, but I already have the outline laid out for you. Okay, they're saying we have some steam that's 100. So when steam is 100, it's ready to turn into water. 100 is the right temperature to make that conversion. So the first thing we have to do is condense that steam back into water. Then they want us to have that steam not be 100 anymore, but cool down to 20. So we're going to have to cool the steam from 100 down to 20. Anytime we're at the boiling point or at the melting point, we're just going to multiply by one number. Okay, this is going to be the 540 again. Okay, it took 540 to boil water into steam. It takes 540 for the reverse to be true. It's just in one direction the energy is given out, and then the other the energy is absorbed. But the math is the same for the counts. So 540 to boil it is just like the 540 to condense it. And this time I did write down that's 243,000 joules. If we're going to cool then the steam from 100 to 20, when we're warming or cooling things, we need to think about the specific heats when things are heating up or cooling down. I'm to the top of the page. I'm looking for steam, and steam's not on that table. So steam is going to be located somewhere else. No, wait. We're cooling, I'm sorry. We condensed it. So we're not cooling steam, we're cooling water. And water is on that table, so that's good news. Cooling water, we would do a 1. Just like here we did a 1. The specific heat when we heated water was 1. When we cool the water, it's also a 1. And then we need a temperature change. We're going from 100 down to 20, so that's a change of 80. 100 minus 20 is 80. That multiplication at that level is 36,000, but you don't have to write those down. What you do have to do is add them up. That would be 279,000 calories. Third one, we have ice that's 0. So the first thing we could do to ice at 0 is melt it. It's ready to melt, it's the right temperature, melts at 0, so we're melting, it's melting time. Then once you've melted it into water, that water could get warmed up from 0 to whatever temperature they desire, which is 40. At every level we need to use the maths, but before we get started with math, let's look to see where we're trying to get with this. We're trying to get to kilojoules. Okay, the joules family is linked to kilograms. So we cannot operate off the 20 grams, so I'm going to take a small stroll to my left and do what I said I was going to do, which is if we're trying to get to joules and they don't give you kilograms, we have to take the 20 grams and do dimensional analysis with this. And the math on this, it gets you a 0.02. So I'll take a walk back to my right. That at both of these levels, 0.02 would get used. If we're melting, we are going to have to multiply one number. So way back to the beginning of that first group of the notes, to melt, we're going to multiply one number, grabbing it from table 12.3. And in the joule kilogram family this time, that is 3.35 times 10 to the 5th. For the warm it up part, we need to go to table 3.4, and we're going to multiply two numbers. Water's number for the joule kilogram family this time is 4.18 times 10 to the 3rd. And if we're going from 0 to 40, we have to subtract those to get a temperature change of 40. This time I did not write that down. I just went ahead and added those up, and it would show 10,044 joules. Kilograms is what these became. Kilograms lead you to joules. And in most settings we'd be done, but they added on one additional aggravation that they ask us to get to kilojoules. So we have one more step to get from joules to kilojoules, which could be a little dimensional analysis thing, because 1,000 joules make 1 kilojoule. 10.0 kilojoules would be fine with me. Your screen, if you divide the 1,000, would be 10.044. and we always copy, and then round that third position, which could just stay a 0, and that would be fine. The longest that these things could go is 5 steps, and I'm going to just do a 5-step one for you, just making up numbers, because there's not one in the book that's a 5-step. So, director from the back, pick me a negative number. Director in the back, pick me a negative number.
-7.
-7. Pick me a number over 100.
120.
120. Do you like grams or kilograms?
Grams.
How many grams?
30.
Do you want me to go to calories or joules?
Calories.
Good. That made our life easier. Grams are going to
I
lead
mean
us.
joules.
No, you spoke too soon. We have our more difficult director with us today, trying to make our life hard. Our assistant director, we'll call her.
Hey.
So grams is readier to lead you directly to calories. If I were going to obey my director, which I'm not, if we were going to joules, we would just have to do a conversion. Grams to make kilograms. Okay. But what we're trying to do with this is go from some super cold ice at -7, it's too cold to melt. So the first thing we'd have to do is warm that up to 0. Then we'd have to melt the ice. Then it's 0 degrees, but it's water. We'd have to warm the water up from 0 to 100. Ice. Once we get to 100, then we can boil it. Then it's steam. Then we could warm the steam up from 100 to the 120, but it's going to take us 5 different steps to do this. They all involve 30 multiplying. When we melt, we've encountered the number for melting before. We're looking at the gram calorie numbers. The melting number from our table would be the 80. For boiling level, that's also easy. It's only one number. That's the 540, because the boiling number is coming from the table 12.1. The other 3 levels where we're warming things up, you're going to have to multiply by 2 numbers. The specific heat for waters had been 1 in the gram calorie club. And the temperature change here from 0 to 100 would be 100. While we're thinking temperature changes, temperature change here from 100 to 120 is 20. And the temperature change here from -7 to 0 is 7. But I would need to access some specific heats for steam and ice that we didn't encounter yet today
You have to do it quickly.
by
You only have
locating
2.5
those,
minutes.
and I'll have to do it quickly. Let's see, they are around here somewhere. I know I had them written down. I know where they are. The specific heat for ice is a 0.500, and I don't think your homework tonight will use that number because it wasn't handy in this section of the book, but it is a 0.500 for specific heat of ice. Specific heat of the steam is a 0.480. I don't think that's going to get used in your homework tonight either, but when you go to do the practice test, which is where I just grabbed this from, there is a question on the practice test that goes through all 5 of these levels, and it will use those numbers because I'm looking at myself right now doing exactly that. I don't have the time to do it because we just made this up spontaneously and we're running out of record time, but we multiply. If you want to write down 5 numbers, go ahead, you could, but you don't have to. But what we would have to do is add those up, and it would be a lot of joules, or a lot of calories, because this alone is 3,000, this is like 16,000. It'd be a good bit of numbering there. Well, that won't happen in the homework, but practice test, I can see it does. So if you have questions, if that's not enough, email me, but I think a good strategy is make a list in English words of what you're doing. Melting is multiplied by 1 number, boiling is multiplied by 1 number, When you heat or cool things, multiply by two numbers, one of which is the temperature change that you have to subtract to do, and just use the right table for the right stuff. See ya.